Hello everyone. In this class, we will introduce the technology development of continuous casting. For more than 150 years till the 1960s, bench casting of liquid steel into ingots for the further shaping by stepwise rolling or forging were the only method available for casting liquid steel into a solid shape. In 1846, Sir Henry Bessemer in the UK first conceived and demonstrated the physical possibility of continuously casting thin sheets of steel between two water-cooled rolls positioned below a stream of liquid steel. However, it took about 100 years to establish the technology of continuous casting on a commercial scale. The first pilot plant for continuous casting of steel was installed in Germany in 1943. Since then, continuous casting has become a long way, and today a staggering 75% of the total crude steel production in the world is continuously cast into one shape or another, such as slabs, blooms, billets, other shapes, as against 30% in 1980. The main advantage of continuous casting is that the product is ready for direct rolling, sometimes even without further reheating. Continuous caster can be classified in a variety of ways. According to the configuration of the continuous caster structure, it can be divided into vertical continuous caster, vertical bending continuous caster, bow-type continuous caster, or arc continuous caster, oval continuous caster, horizontal continuous caster, etc. According to the shape and size of a billet section, it can be divided into billet caster. It means if the section is not more than 150 mm x 150 mm, it is called billet. If the section is more than 150 mm x 150 mm, it is called bloom. The second is slab caster. It means the section of the slab is rectangular, and its width thickness ratio is generally more than 3. Next one is round billet caster. It means the section of the billet is round with a diameter of 60 to 400 mm. Next one is beam blank continuous caster. It means the casting special section such as profile, hollow tube, etc. Next one is continuous caster for both billet and slab. On one caster, it can cast both slab and billets. The last one is thin slab caster. Thin slab with thickness of 40 to 80 mm, etc. Compared with traditional ingot casting, continuous casting has the following advantages. First, simplifies the production process and shortens the technology process. The continuous casting process eliminates the processes of demolding, die-forming, ingot heating, and blooming. The appearance of thin slab caster further simplifies the technology process. Compared with traditional slab continuous casting, thin slab continuous casting saves roughing mill process. the production cycle from molten steel to sheet metal is greatly shortened. Traditional slab continuous casting takes about 40 hours, while thin slab continuous casting only takes 1 to 2 hours. Second, improved metal yield. By using the die casting process, the loss of cutting head and tail from the molten steel to slab is 1% to 20%, while that of continuous casting is 1% to 2%. So, the yield of metal can be increased by 10% to 14%. For example, slab 10.5%, blue 13%, billet 14%. If the steel plant with an annual capacity of 1 million tons of steel is calculated to increase by 10%, the production of 100,000 tons of steel can be increased by adopting the continuous cutting process. The economic benefits are considerable. Third, reducing energy consumption. The reheating process of soaking bit is eliminated by continuous casting, and the energy consumption can be reduced by 1/2 to 1/4. Usually, in the production of its billet, the continuous casting can save 400 to 200 mg, which is equivalent to saving 10 to 30 kg heavy oil fuel. If the continuous casting slab adopts hot delivery and direct rolling process, the energy consumption can be further reduced, and the processing cycle can be shortened. The fourth, the production process mechanization, high degree of automation. After adopting continuous casting, the labor environment has been fundamentally improved. Because of the improvement of equipment and operation level, the whole process computer control, and management. Continuous casting operations, automation, and intelligence have become a reality. The fifth, continuous casting steel grade expands, and the production equality is improving. At present, almost all kinds of steel can be produced by continuous casting. More than 100 kinds of continuous casting steel have been expanded to include super clean steel, high-grade silicon steel, stainless steel, Z-direction steel, pipeline steel, heavy rail, hard wire, tool steel, and alloy steel. Moreover, the quality of continuous casting slab is better than that of the ingot. However, in the present case, continuous casting is not a complete substitute for the production of ingot casting, because the properties of some types of steel are not yet suitable for the production of continuous casting, or it is difficult to guarantee the quality of the steel when using continuous casting. For example, some small batch products and some large-scale forging that must be forged parts, and some large-scale rolled products essential. Therefore, it is still necessary to retain parts for the production mode of mold casting and strive to improve the quality of steel. That's all for today. See you next time.